This is DAT22103, Cloud Computing. Today we will cover Chapter 2, Part 1, Cloud Computing Technology. In Chapter 2, Part 1, we will cover three main topics: infrastructure and hardware, access to cloud computing, and storage space in cloud computing. Cloud computing depends on infrastructure to operate. It provides three core resources: computing power, storage capacity, and network connectivity. Infrastructure is the foundational layer of the cloud. Let us look at what cloud infrastructure really means. Cloud infrastructure refers to the physical and virtual resources used to deliver cloud services. In simple terms, it is everything working behind the scene to make the cloud function. It includes four key components: physical hardware, such as real servers and data centers; virtual machines, which are computers created inside those servers; networking systems, which connect everything like roads connecting towns; and storage systems, which keep your data safe, like a digital warehouse. All these resources are owned and managed by cloud providers. Cloud infrastructure is built on real hardware components like servers, storage devices, and network equipment. These are housed inside secure data centers, and users never interact directly with this hardware. A server is a powerful computer that runs applications and processes data. In cloud computing, one server supports many users, workloads are balanced automatically, and users pay for usage, not ownership. In cloud computing, providers offer computing power as a service. You do not need to buy an expensive computer. You simply rent what you need. Users can choose CPU size depending on the workload. For example, editing a simple document needs small CPU, but running a data analysis project needs more processing power. You can also adjust memory by configuring RAM. If your system runs many applications at once, you increase the RAM. You can scale resources up during busy periods, like online sales, and scale down when traffic is low. This flexibility is not possible with traditional computers. Virtualization concept means one physical machine can run many virtual machines. A physical machine is the real hardware, like a server. A virtual machine is a software-based computer created inside that server. Each virtual machine acts like a real computer. It can run programs and store files. It runs its own operating system, such as Windows or Linux, separately from others. It is isolated from others, which means if one virtual machine crashes, the others are not affected. Think of it like one apartment building with many separate units. Each unit works independently. Virtualization improves efficiency and flexibility because one physical machine can serve many users. A virtual machine, or VM, is a software-based computer with full hardware emulation. VMs offer rapid provisioning, can easily be turned on or off, and scalable resources, making them essential for cloud infrastructure. The hypervisor is the software that creates and manages virtual machines. It controls hardware usage and keeps VMs separated, ensuring fair and safe resource sharing for scalability. Cloud storage relies on physical hardware like hard disk drives and solid-state drives. A multi-device strategy ensures reliability and fault tolerance. Users interact with storage as a service, abstracting the physical disks. Networking hardware connects users to cloud services and links cloud services to each other. Routers direct data between networks. Switches connect devices within the same network. High-speed links move data very fast. A strong networking infrastructure is required. The outcome is fast and stable access to cloud services. A data center is a secured facility housing cloud hardware. It includes essential systems like power backup, cooling, physical security, and fire protection. Data centers support continuous cloud operation. Cloud users do not manage hardware due to the high technical expertise required, the complexity of maintenance, and the need for rapid failure response. Cloud providers handle all infrastructure management. Cloud infrastructure is shared among many users. This sharing is made safe and efficient through virtualization, access controls, and resource isolation, which also reduces cost. The key benefits of cloud infrastructure include scalability, high availability, cost efficiency, and on-demand resources. Organizations gain strategic value by avoiding large upfront investments. Next, we will discuss 2.2, access to cloud computing, covering how users connect and interact with cloud services. Meaning of cloud access refers to how users connect to cloud services to retrieve data and applications. In simple terms, it explains how you reach the cloud. Access is usually provided through internet connections. For example, when you open Google Drive using Wi-Fi at home or mobile data on your phone. It also uses secure protocols, such as HTTPS, to protect your information. This keeps your password and data safe. Because of this, users can access services anytime, anywhere, whether at home, campus, or while traveling. Cloud services can be accessed using a wide range of devices, including desktop computers, laptops, tablets, and smartphones. No special hardware is required, only internet access is needed. Many cloud services, such as email and online storage, are accessed directly through a web browser. Key advantages include no installation needed, ease of use, and platform independence. Application-based access means some cloud services need dedicated applications, not just a web browser. These apps connect to servers and establish secure links to cloud infrastructure. For example, the Dropbox app on your laptop connects directly to the cloud. They also sync automatically, so when you edit a file on your phone, it updates on your laptop in real time. They offer advanced features beyond browser limits, like full editing tools in Office 365. Network connectivity requirement means cloud access depends heavily on network quality. If your network is weak, your cloud service will also feel slow. There are 3 key factors. First, internet speed. This is how fast data moves. For example, downloading a large file is faster with high speed. Second, network stability. This means your connection does not keep disconnecting. Imagine attending an online class, and the line keeps dropping. Third, latency. Latency is the delay before data starts moving. It is like the waiting time after you click a button. High latency causes lag, especially in video calls or online games. Poor connectivity affects performance and user experience, meaning the system feels slow and frustrating to use. Secure access to the cloud means cloud access must be secured to protect data. When you store files online, you must make sure only the right people can open them. First, login credentials. This means your username and password. It proves who you are, like showing your ID card before entering a building. Second, encrypted connections. Encryption changes your data into a secret code while it travels on the internet. Even if someone intercepts it, they cannot read it. Third, access controls. This decides who can view, edit, or delete data. For example, a student can view notes, but only a lecturer can edit them. Security is essential for cloud trust because users must feel safe when using cloud services. User authentication means confirming user identity. Before you enter a cloud system, the system must check who you are. The most common method is username and password. You type your username and password to prove your identity. It is like using a key to unlock your house. Another method is multi-factor authentication. This means using more than one proof. For example, after entering your password, you also receive a code on your phone. This extra step makes it harder for hackers to enter. Without authentication, access is denied. The system will block you because it cannot confirm your identity. Authorization in cloud access controls what users are allowed to do. After the system confirms your identity, it decides your permissions. Authorization defines 2 things. First, resource access, which means which resources can be accessed. For example, a student can open lecture notes but cannot access exam papers. Second, permitted actions, which means what actions are permitted. You may be allowed to read a file, but not edit or delete it. Think of it like a library card. You can enter the library, but some rooms are only for staff. Authentication comes before authorization. The system must know who you are before giving access. Remote access advantage means cloud access allows remote work. You do not need to be in the office to do your tasks. First, location independence. This means you can access data from different locations. For example, you can open your assignment from home, campus, or even while traveling. Second, collaboration. You can work collaboratively with teams. For example, 3 students can edit the same document online at the same time. Third, continuity. This means you can continue tasks without physical presence. Even if the office is closed, work can still go on. This supports modern work environments, where flexibility is important. Access reliability means reliable access ensures the cloud service is always connected. You can use the system without worrying that it will suddenly stop. First, continuous service. This means the system runs all the time, like online banking that is available 24 hours. Second, minimal downtime. Downtime means the system is not working. Reliable cloud systems reduce this as much as possible. Third, user satisfaction. When services are stable and fast, users feel confident and happy. Cloud providers design systems for high availability. which means the service is ready and accessible most of the time. Now we will cover Section 2.3, which focuses on storage space in cloud computing. What is cloud storage? Cloud storage allows users to store data on remote servers. These remote servers are powerful computers located in data centers, which may be in another city or country. They are managed by cloud providers, not by you. Data is accessed through internet connections and cloud services. Cloud services are online platforms like Google Drive, OneDrive, or Dropbox that allow you to upload, download, organize, and share files. They provide the interface and tools to manage your stored data. For example, you upload a file using Google Drive at home and later open it on campus using your phone. Because of this, users do not need local storage devices. Your data stays online and is easy to access anytime. Purpose of cloud storage means the main reasons we use it in daily life. Cloud storage is used to save files, such as assignments, photos, or documents, safely online instead of only on your laptop. For example, you store your assignment in Google Drive. If your laptop has a problem, your file is still safe online. It is also used to back up data. Backup means keeping a copy of your files in case your device is lost or damaged. For example, your phone can automatically back up photos, so even if your phone is lost, your pictures remain in the cloud. You can share information by sending a link to friends or teammates instead of using a USB drive. Everyone can view or edit the same file. Cloud storage also supports applications. Apps like WhatsApp or online banking store data in the cloud, so you can access your account on another device. The key benefit is that it supports both personal and business use. Cloud storage can store various types of data. This includes documents like assignments, images such as photos, and videos like recorded lectures. It also stores application data, which means data used by apps, and system backups, which are full copies of your system. It supports structured data, like tables, and unstructured data, like photos and videos. Storage as a service means storage is provided as a service, not as hardware you buy. Users can increase storage size when they need more space, like during a big project. They can reduce storage usage when files are no longer needed. You pay based on consumption, meaning you only pay for the space you use. This avoids buying physical storage devices. Data redundancy means cloud storage uses data redundancy to keep your files safe. Redundancy means creating extra copies of the same data. This means multiple copies of data are stored in multiple locations. For example, when you upload a document, one copy may be stored in a data center in Singapore and another copy in Kuala Lumpur or even another country. If one server has hardware failure, which means the physical machine breaks down, your data is still available from another data center. Think of it like keeping copies of important notes in different cities. Redundancy improves reliability because your data remains safe and accessible, even if a problem happens. Cloud storage is designed for high availability, allowing 24/7 access to data regardless of location. Users benefit from fast retrieval speeds and can maintain productivity even during hardware failures, which is critical for reliability. Data backup in the cloud means cloud storage supports backup and recovery mechanisms. Backup means keeping a copy of your data. Recovery means getting it back when something goes wrong. Backups help to prevent data loss. For example, if your laptop is stolen or damaged, your important files are still safe in the cloud. They also help you recover from accidental deletion. If you delete a file by mistake, you can restore it. Backups can restore system operations after system failures, so business continuity continues even after technical problems. Backup is a key cloud advantage because it protects your data and keeps work running. Security of cloud storage means keeping your protected data safe. Cloud storage security includes encryption, access controls, and monitoring. Encryption changes your data into secret code. For example, when you upload a file, it is scrambled so others cannot read it. Access controls decide who can open or edit the file. For example, only your group members can view the project document. Monitoring means the system watches for unusual activity, like someone trying to log in many times. The key benefit is that security protects stored data from unauthorized access, which means people without permission cannot see or change your files. Cloud storage offers easy scalability. Users can start small, expand quickly when necessary, and avoid fixed storage limitations. This dynamic approach effectively supports growing data needs. Cost efficiency of cloud storage means cloud storage reduces cost in several ways. First, eliminating hardware purchases. Organizations do not need to buy expensive physical devices or servers. This avoids large upfront capital investment, which means paying a big amount of money at the beginning. Second, reducing maintenance. There is no need to repair or update local hardware because the cloud provider manages it. Third, charging based on usage. This is a pay-as-you-go model. You only pay for the storage you consume, just like paying for electricity. That is why it is budget-friendly and suitable for organizations with limited budgets. This slide shows the relationship between infrastructure, access, and storage. Infrastructure provides the foundation. Foundation means the basic structure that supports everything, like the building of a house. In cloud computing, this includes servers and networking hardware. Access allows users to connect. For example, you use the internet on your laptop or phone to reach the cloud. Storage holds data and information, such as documents, photos, or system files. All three work together to deliver cloud services. Without infrastructure, there is no system. Without access, you cannot connect. And without storage, there is nowhere to keep data. Let us look at the Chapter 2, Part 1 summary and the key takeaways. First, cloud runs on real infrastructure. This means real servers, networks, and data centers are working behind the scenes. Second, virtualization enables sharing. One physical server can run many virtual machines, so resources are used efficiently. Third, secure access is essential. Authentication, authorization, and encryption protect your data. Fourth, storage is scalable and reliable. Scalable means you can increase or reduce storage when needed. Reliable means your data stays available. These are the core concepts. This completes Chapter 2, Part 1. Thank you for watching this video on cloud computing. Cloud powers innovation, and we must manage it with responsibility.